What's going on, everybody? Welcome back to the channel. We have this nice and interesting question that we're going to be solving that says find the values of x and y given that x cubed minus y cubed is equal to 91. Now notice at the left hand side, x cubed minus y cubed has an identity of x minus y times x squared plus xy plus y squared, and this is equal to 91. This means that x minus y and x squared plus xy plus y squared are a pair of integer factors of 91. So what are the pairs of integer factors of 91? I'm going to be writing them here. We have 1 times 91. We also have 7 times 13. So since we have 91, which is positive, that means negative factors are also possible. So we can also have negative 1 times negative 91. We can have negative 7 times negative 13. But this is not all. We can alternate. That means we also have other factors like 91 times 1. Then we have 13 times 7. And we have negative 91 times negative 1. And then we can also have negative 13 times negative 7. But then notice something. X squared plus xy plus y squared is always positive. And if that is the case, that means we're going to be ignoring the negative factors of 91. So we ignore this. We also ignore this. We ignore this. And we ignore this. So we have 4 factors to work with. So let's call this first factor, which is x minus y. Let's say this is A. Then let's call this other one, which is x squared plus xy plus y squared to be B. Now from this first factor, I can move negative y to the right hand side so that I have x to be equal to A. And as negative y crosses to the right, it becomes plus y. Now let's substitute this for x in this other equation. So this is x squared, which means I can write a plus y all squared in place of x squared plus x. Remember, x is a plus y times y plus this is y squared, and this is equal to b. Now let's expand this. On expanding, we have a squared plus 2ay plus y squared from expanding this. Plus, now let's expand this. Y times a is ay plus y times y is y squared plus y squared, and this is equal to b. Now let's add up like terms. We have y squared plus y squared plus y squared, which means 3y squared. Now we have 2ay plus ay gives 3ay. And then we have a squared. So I'm going to be writing plus a squared. And when I move b to the left hand side, it becomes minus b. And this now equals to 0. Let me put this inside parentheses. Good. Now let's take our first factor, which is this. Now we are using a and b as the factors. Using the first factor, we have 1 and 91. That means our a is 1 and our b is 91. Let's substitute that into this equation. Now I'm going to be asterisking this because we're going to be using it more often. So we have 3y squared, so 3y squared plus 3ay, that is 3 times a is 1, y plus a squared, that will be 1 squared, minus b is 91, so 91, this is equal to 0. So this results in a quadratic equation of 3y squared plus 3 times 1 times y is 3y plus 1 squared is 1 minus 91, that will be negative 90. So I have negative 90 here. I'm going to be putting negative 90 here. And this is equal to 0. Now let's reduce this quadratic equation. So by dividing by 3, so divide by 3, divide by 3, divide by 3, and divide by 3. This cancels out, we have y squared, plus, this cancels out, we have y, minus 90 divided by 3, we're going to be having 30. And this is equal to 0 divided by 3 is 0. So this is a nice quadratic equation that can be factorized. So what are the factors of negative 30? We can use 6 and negative 5. The reason? 6 times negative 5 gives negative 30. And when we add them, we're going to be having the coefficient here 1. Good. So we have factorized y plus 6 times y minus 5 to be equal to 0. So there are two cases here, which is y plus 6 equal to 0 or y minus 5 is equal to 0. And from the first case, we move 6 to the right-hand side so that we have y to be equal to negative 6. For the second case, we move negative 5 to the right-hand side so that we have y to be equal to positive 5. Now recall that our x is equal to a plus y. So let's get a value for x. Our x is equal to a plus y. So we're going to be substituting when y is equal to negative 6. So this makes our x to be equal to a. Remember, our a is 1 from the first case, plus y. Y is negative 6. So 1 plus negative 6 gives negative 5. Now, when y this time is equal to 5, we substitute here once again. So we have x to be equal to a. A is 1 plus 5, which is the value of y, and this gives 6. So the pair of solution that we have for x and y from here is equal to x negative 5 when y is negative 6. And we have x to be 6 when y is 5. Good. Now let's move on to our second case, which is case 2. Our case 2 is when we use this factor, 7 and 13. And we're going to be substituting this into this equation that we start. So our case 2, we have a and b, which are the pair factors. So we are using 7 and 13. So our a is 7 and our b is 13. So this becomes 3y squared plus 3 times a is 7, y plus a is 7 squared minus b is 13. And this is equal to 0. And then simplifying, we have 3y squared plus 3 times 7 times y, that will be 21y, plus, now 7 squared is 49. 49 minus 13 will be 36. And this is equal to 0. Now we can divide through by 3. So divide by 3, divide by 3, divide by 3, and then divide by 3. 3 cancels out, leaving y squared plus 21y divided by 3. I'm going to be having 7y. And then plus 36 divided by 3, that will be 12. This is equal to 0 divided by 3 is 0. Now, this equation can also be factorized. So the factors of 12 that we're going to be using will be 4 and 3. 4 times 3 is 12. By 4 plus 3 is 7. Good. So the factor now become y plus 4 times y plus 3. And this is equal to 0. So we have two cases. We have y plus 4 to be equal to 0, or we have y plus 3 to be equal to 0. For the first case, y will be equal to, as 4 crosses to the right, it becomes minus 4. Or for the second case, y will be, as 3 crosses to the right, it becomes minus 3. So we have two values for y. Now recall that x is equal to a plus y. Now let's get our corresponding value for x. We start with when y is equal to negative 4. Now let's substitute that here. So x will be a plus y, which is negative 4. Oh, sorry, I didn't put the value of a. A is 7, so I'm going to be putting 7 here. So this will be 7. So we have 7 plus minus 4, that will be 3. Good. Now this time, when y is equal to negative 3, so let's substitute that here. So we have the corresponding value for x to be equal to a. Remember, a is 7 plus y, negative 3. So this will be 7 plus negative 3 will be 4. Good. So the corresponding values for x and y, or the factor pairs, are, for the first case, x, we've got 3, y is negative 4. Then for this other case, we've got x to be 4, y to be negative 3. Very good. Now let's move on to other factors of 91 that we are working with. We have two factors remaining, which are this and this. We're not going to be working them. The reason is because the discriminant from the equation they produce is negative, which means we're going to be having complex solution. But we are only focused on real number solution for x and y. So we're going to be leaving this behind. So our focus will be on the real values for x and y. Well, feel free to share your ideas in the comment section below. And if you enjoyed this video and have learned something from this video, go ahead and give this video a thumbs up. Subscribe if you haven't. Turn on the notification bell so you don't miss my upcoming videos. And like I always say, until next time, take care.